Here's a problem that sounds impossible. You've got a billion pieces of information, documents, images, products, each turned into a point in space. Someone asks a question. To answer it, you need the handful of points closest to their question, out of a billion, and you need it in milliseconds. Check them one by one. You'd be waiting until the heat death of the universe. So how does every AI search, every recommendation engine, every chatbot over your own documents do this instantly? The answer is a special kind of database, a vector database, and the clever trick at its heart is genuinely beautiful. Let's break it down. Quick bridge, 15 seconds, in case you missed my embeddings video. An embedding turns meaning into a point in space where similar things sit near each other. Cat lands near kitten and tiger. Now a normal database is built for exact matches. Find the row where the name equals cat. Boom, done. But that's useless here. We don't want the row that says cat. We want everything that means something similar to cat. And similar isn't an exact match. It's a distance in space. Normal databases match values, not meaning. So we need a database built around one question. What are the nearest points to this one? That question has a name, Nearest Neighbor Search. So how do you find the nearest points? The obvious way: measure the distance from your query to every other point, then keep the closest few. This actually works. It's called brute force and it is perfectly accurate. With 1,000 points, it's instant. The problem is scale. The work grows with your data. 1,000 points, 1,000 checks. 1,000,000,000 points, 1,000,000,000 distance calculations for every single search, and you might be running thousands of searches a second. Brute force doesn't scale. It hits a wall and dies. So the whole game becomes this: how do you find the closest points without checking all of them? Here's the key insight that unlocks everything. Ask yourself, do you actually need the mathematically perfect closest results? For finding a similar document, a relevant product, a matching photo, almost perfect is completely fine. If the true best match was the closest point, and you hand back the second closest instead, nobody notices. Nobody cares. So vector databases make a trade. They give up a tiny bit of accuracy, returning the very close instead of the guaranteed closest. And in exchange, they get a staggering amount of speed, thousands of times faster. This is called Approximate Nearest Neighbor Search. ANN, and approximate is the magic word. Good enough instead of perfect is what makes billion-scale search possible. But how does it skip almost every point and still land in the right neighborhood? Two beautiful ideas. You don't need the math, just the intuition. Two main strategies. Idea 1. Neighborhoods. Before anyone searches, you pre-sort all the points into clusters, like dividing a country into postal zones. Now when a query comes in, you don't search the whole country. You work out which zone the query belongs to, and only search inside that zone. You just eliminated 99% of the map without checking a single point in it. Instant, massive shortcut. Idea 2, and this is the one powering most modern systems, a graph. Imagine every point is connected to its nearest friends, forming a giant web, a social network of ideas. To search, you drop in anywhere and just keep asking, which of my friends is closer to the target? Hop to that one. Ask again. Hop again. It's friend of a friend, zooming in on the answer in a handful of jumps, instead of walking past everyone in the building. There's a famous version of this called HNSW, but forget the acronym. Just remember, it navigates to the answer instead of scanning for it. So in practice, what does a vector database actually give you? It's the whole package that makes this real at scale. You pour in your data, documents, images, whatever, and it stores the embeddings and builds those clever indexes automatically. When a query comes in, it runs that fast approximate search and hands back the top matches in milliseconds. But it also handles the boring but critical stuff. It scales to billions of vectors across many machines. It lets you add and delete data live, without rebuilding everything from scratch. And it lets you mix in normal filters, find similar products, but only ones in stock under $50. You've probably heard the names: Pinecone, V8, Milvus, Quadrant, and plenty of others, plus classic databases bolting vector search on. They're all solving one core problem: fast similarity search at massive scale. And here's the thing, you use this constantly, you just didn't know its name. Every recommended for you, every find similar, every search that reads your intent instead of your keywords, vector database doing its thing. But the biggest one for AI engineers is RAG, Retrieval Augmented Generation. Remember, a model's knowledge is frozen at training time, and it cannot see your private documents. RAG fixes that, and the vector database is its engine. Your question gets embedded. The vector database instantly finds the most relevant chunks of your documents. Those get handed to the model so it can answer from your data. No vector database, no RAG. It's the retrieval that makes chat with your docs possible at all. So that's a vector database. It takes meaning as points from embeddings and answers one question at massive scale. What's closest to this? It wins by being brilliantly lazy, refusing to check everything, trading a sliver of perfect accuracy for thousands of times more speed. Neighborhoods to throw away most of the map, and friend of a friend hops to leap straight to the answer. It's the quiet engine under AI search, recommendations, and RAG. Subscribe for AI explained visually, and tell me in the comments, knowing that it's approximate, does that make you trust AI search more or less?